Hello everyone, this is your friendly neighborhood student teacher, Mr. Dement. So for Algebra 2 today we're going to be going over graphing rational functions. So this is 5.4, day 1, and it's titled Graphing Rational Functions. Okay, so we've been talking a lot about rational functions. We've talked about simplifying them, finding an LCD, even solving for them. So getting down to an answer like x equals 2 or x equals some number, or even x equals multiple numbers. Okay, so today we're just going to touch back on graphing rational functions, and we kind of introduced this briefly, but we're gonna go back over it again today. So to start with, let's just recall what a rational function is. A rational function is just a function, we'll call it f of x, that has two polynomials in it. So we could say n of x over d of x. My initials. Okay, let's also recall that the parent function for a rational function is just 1 over x, the function 1 over x. So remember, parent functions are things that we've known and we've seen them before. So x squared, x cubed, square root of x, those are all parent functions. And the rational parent function is 1 over x. And if we remember, this function is a hyperbola, and it actually branches off in two different ways. So it has two branches. If you don't remember what that looks like, it might be good to take a second and graph it. Okay, so before we begin, let's also recall a couple more important things. To find the x-intercepts of a function, what do? We set something equal to 0. Take just a second and fill this in. Pause the video, try to complete this on your own. And then also tell me what the y-intercepts, how we would find the y-intercepts. We would set something else equal to 0. Pause this and fill the rest of this, complete these sentences. Okay, so to find the x-intercepts, we set y equal to 0. I hope you're able to remember that. And to find the y-intercepts, we take x and set it equal to 0. Okay, so we're going to be using that to do a couple examples here. So find the x and y intercepts for each function. Okay, so to start, our first example is f of x is equal to x squared plus 3x minus 4 over x minus 2. Okay, we'll start by finding the x-intercepts. And then we'll find the y-intercepts. So just like we said earlier, to find the x-intercepts, we take y and set it equal to 0. So f of x, remember f of x is the same thing as y. So I'm going to say 0 is equal to x squared plus 3x minus 4 over x minus 2. Okay. I can factor this numerator into x plus 4 times x minus 1 over x minus 2. Now, what makes this fraction, or what makes any fraction go to 0? It's where our numerator is equal to 0, because 0 divided by something is always 0. Okay? So to find what makes this function go to 0, all we really need to do is take our numerator and set it equal to 0. So we get x is equal to negative 4 and x is equal to 1. Okay? And I want everyone to highlight this, circle this, put a star next to it, something. But our x-intercepts are also called our zeros of a function. Do you remember that? These are the zeros of our function. Okay? And so to find the points of each of these, remember, we took y and set it equal to 0, so we can say that our coordinate points are -4 and 0, because remember we set y equal to 0 to find the x-intercepts. And then the other one is 1, 0. Okay, moving on to the y-intercepts. We leave y alone and set x equal to 0 this time. So I have y is equal to 0 squared plus 3 times 0 minus 4 over 0 minus 2. So I get y is equal to -4 over 2, which is equal to just 2. So my y-intercept is 0, 2. Now where did this 0 come from? Remember, to find the x-intercepts we said, to find the y-intercepts we take x and set it equal to 0. Okay? So here's our y-intercept, and here are our x-intercepts, or our zeros. Okay? Moving on to another example. So g of x is equal to 2x squared over x squared minus 9. We're going to find the x-intercept and the y-intercepts. Okay, so we set y equal to 0, and then we have 2x squared over x squared minus 9. Alright, so where does our numerator equal 0? Here we actually don't even need to factor. We can just take our numerator and set it equal to 0. Well, this is easy. X has to be equal to 0 then. Okay, so our x-intercept is 0, 0. To find our y-intercept, we keep y and set x equal to 0 this time. So I get y is equal to 2 times 0 squared over 0 squared minus 9 is equal to 0 over 9, which is equal to 0. So our y-intercept is also 0, 0. Okay, there are x and y-intercepts. Pause this video if you need to take a minute to let it sink in, or if you need to copy something else down a second time. Okay, h of x now is equal to 2 over x minus 4. We're going to find our x-intercepts and our y-intercepts. Okay, so for our x-intercepts, again, we take y and set it equal to 0. So we have 0 is equal to 2 over x minus 4. Now, what makes this fraction go to 0? Right, so we take the numerator and set it equal to 0. Now, when does 2 equal 0? That doesn't even make sense, actually. So we actually have no x-intercepts. Okay, for our y-intercept, we take y, we keep y, and this time we set x equal to 0. So we have 2 over 0 minus 4. Okay, simplifying this, I get y is equal to 2 over minus 4, which is -1/2. So our y-intercept is 0, -1/2. Okay? We'll move on to another example, another part of this lesson. Okay, so here we're given a function f of x, is equal to x plus 3 over x plus 2. Here's the graph of that function. Okay, take a minute and copy that down for just a second. Pause the video. Okay, so the domain of any rational function is all real numbers except where what? So if we have a rational function, where would we have issues with our domain? The domain is all real numbers except for the x values that make our denominator equal to 0. Okay, so in this example, we have f of x is equal to x plus 3 over x plus 2. What would make our denominator equal 0? So literally, I'm going to take x plus 2, set it equal to 0, and we get x is equal to negative 2. So we have what's called a vertical asymptote at x equals negative 2, and you can see that on this graph. If you look at x equals negative 2, do you see how that's a vertical asymptote there? Okay, so like we said, the domain is all real numbers except for these values that make our denominator equal to 0. So our domain is simply negative infinity to negative 2 union negative 2 to infinity. This is all real numbers except for what makes our denominator equal to 0. Okay? Now, here are a couple graphs, three graphs actually. Pause the video, take just a second, and write down for each graph what their asymptotes are, their vertical asymptotes, if they have any. Write them down below each of these graphs. Pause the video now and do that. Okay, I got x is equal to 1 for the first vertical asymptote, x is equal to 0, and then in this last one I actually have two asymptotes. X is equal to negative 2 and x is equal to 3. Okay? And we can see that just looking at the graphs. Now I'm going to give you a list of functions. And I want you, based off of what we just found, their asymptotes, I want you to match these functions with their graphs, these three graphs here. So which graphs correlate with which of these functions? So these asymptotes here tell us that these numbers are where our denominators equal 0. So based off of that, we can say our denominator for this function would go to 0 when x equals 1. Which one of these goes to 0 in the denominator when x equals 1? Right, it's going to be this one on the right, h of x. So h of x belongs to that graph. Which denominator goes to 0 when x is equal to 0? It's going to be f of x, because x is in the denominator, and we said our asymptote is x equals 0. Okay, we do the same thing for this graph, and we see that g of x, its asymptotes are x equals negative 2 and x equals 3. And we can find those by setting the denominator equal to 0. Okay? So we're going to take just a couple minutes and do some examples of what we just did. We're going to find the domain and the vertical asymptotes for each of these functions. So f of x is equal to x minus 2 over x plus 2. I want you to give me the domain and any vertical asymptotes that exist. I think it's easier to start by finding the vertical asymptotes and then find the domain. So to find any vertical asymptotes, we said that we can take the denominator and set it equal to 0. So the denominator goes to 0 at x equals negative 2. So we have a vertical asymptote at x equals negative 2. Now remember on this last page of notes, we said that the domain is all real numbers except for what makes our denominator go to 0. So we can say that our domain goes from negative infinity to negative 2, union negative 2 to infinity. Okay? Our next function is 2 times x squared minus 9 over x squared minus 4. And actually, if we factor this out, it makes things a lot easier to see. So factoring this, I get x plus 3. 2 times x plus 3 times x minus 3. It's a difference of 2 squares. Over x plus 2 times x minus 2. And I want the domain and vertical asymptotes. The vertical asymptotes are where our denominator equals 0. So I get x is equal to negative 2 and positive 2. So we have vertical asymptotes at x equals negative 2 and positive 2. Now our domain is all real numbers except for these two. So our domain goes from negative infinity to negative 2, union, negative 2 to 2, and then union 2 to infinity. Okay? Number 6, our function is f of x is equal to 4 over x squared plus 3x. Factoring the denominator, I get 4 over x times x plus 3. I'm going to start, again, by finding my vertical asymptotes. Do them in whichever order that is most comfortable for you. I think it's easier to start by finding the vertical asymptotes. Again, our vertical asymptotes are what make our denominator equal to 0. By the zero product rule, we get x is equal to 0 and x is equal to negative 3. Guys, if this is giving you trouble, come in and see me. I'd be happy to remind you of why this is true. Don't let this be something that confuses you. So we have vertical asymptotes at 0 and x equals negative 3. And our domain goes from negative infinity to negative 3, union negative 3 to 0, and then union 0 to infinity. Okay, one last example. F of x is equal to x squared minus 4 over x squared plus 4x plus 3. Again, factoring that, I get x plus 2 times x minus 2 in the numerator, and x plus 1 times x plus 3 in the denominator. Okay, so finding my domain and vertical asymptotes. To find the vertical asymptotes, I set the denominator equal to 0. X plus 1 times x plus 3 is equal to 0. That gives me x is equal to negative 1 and x is equal to negative 3. Which means our domain goes from, I'm going to run out of room, so I'm going to write it up here, negative infinity to negative 3, union negative 3 to negative 1, union negative 1 to infinity. Okay, that's all for this lesson. I hope this helps. Come in and see me if you have any questions. I'd be happy to help you guys out. Thanks for watching.